Hello there, and then welcome to another video. So in this video we'll be treating bounded and monotonic sequences. Okay, so in the previous video we started with sequences. In case you haven't watched that, kindly do so that you get to understand what we're about to treat in this video. Again, in case you are new to this channel, I would urge you to subscribe to the channel, turn on your post notification so that you don't miss out on any uploaded video. And then once again, we would like to thank new and then old subscribers. Okay, right, without further much ado, let's just dive right into this video. So for monotonic and then bounded sequences, we normally apply them in solving sequences. That's algebra 2. Okay, that's calculus with analysis. Okay, right. So for bounds, okay, we already treated bounds and in 0.6 neighborhood. Okay, but this is a bit different. That's why I initially stated that whatever we treat in the previous videos, we'll also apply them in future videos. Okay, so when we talk about bounds, we have upper bound, okay, and then lower bounds. Okay, so we have this is how we represent them. So the upper bound is being represented with an uppercase M. Okay, that's our upper bound, and then we have lowercase m representing lower bound. Okay, right. Now, so this is how we represent this in the form of a number line. So we know that this is a sequence. Okay, so we have the sequence has to be greater than or equal to the lower bound. Okay, and it has to be less than or equal to the upper bound. Okay, keep this in mind. It's very important. Okay, it's very important. Okay, the sequence has to be greater than or equal to the lower bound, and then also will be less than or equal to the upper bound. Okay, so let me rewrite that. Okay, we have our sequence to greater than or equal to the lower bound, and then less than or equal to the upper bound. Now let's proceed. Okay, let's proceed. So you know that we've already established this. Okay, so now if this is how we come across, whenever you come across bounds in sequences, this is how we try identify them. Okay, it's very important. Once you know this, you are good to go. Okay, right. So note that if the sequence of n, okay, is less than the sequence of n plus 1, okay, it means that we have a monotonic increasing. So we are done with bounds. Okay, this is how we represent bounds. Okay, m is upper bound, lowercase m is lower bound, and then this is how we represent them in the form of intervals. Okay, now let's look at monotonic sequences. Okay, so whenever you come across any monotonic sequence and then the initial sequence is less than the sequence with 1 added to the term, it means that is monotonic increasing. Okay, monotonic increasing. This monotonic increasing. Okay, this monotonic increasing. That's when we have the sequence being less than the sequence where the term is or the term has 1 added to it. Okay, or in short, in simple terms, we have whenever you come across un, okay, which is less than un plus 1, means that you have monotonic increasing. Okay, this is strictly increasing. Okay, it is strictly increasing, and then this is the first point. Now the second point, still under monotonic. So this was under bounds. Okay, now we are treating monotonic. Okay, monotonic. Right, so again, if, okay, so this is if un is less than un plus 1. Now let's say if un plus 1, okay, is rather less than un. Okay, so your guess might be right. Okay, this monotonic decreasing. Okay, so this monotonic Now this summarizes our entire topic. Okay, and a bounded and monotonic sequence. Okay, let me go over it again so that you get to understand. For bounds, okay, that's bounded. Okay, bounded sequence, we have upper bound and lower bound. we have m, uppercase m being represented as what? The upper bound, lowercase m being what? The lower bound. And then this is how we represent them in the form of what? Intervals, okay? Now, and then for monotonic, okay? Monotonic sequences, we have what? Two things you need to know, okay? Whenever you have un less than un plus 1, it's what? Monotonic increasing, okay? And then whenever you have what? un plus 1 being less than what? Un is what? Monotonic decreasing. Now, let's take an example so that you get to understand the whole concept, okay? Right, so let's say an example, okay? We have to show that the sequence, okay? Show that the sequence, so now this is the sequence, n plus 1 divided by what? N is A, okay? Is A. Monotonic, okay? A monotonic decreasing. Monotonic decreasing sequence, okay? And then B, a bounded sequence, okay? So bounded sequence. Now, this is a question, okay? So let me give you a gist. Once you stay to the end of this video, you get to know that I will introduce a simple trick, okay, which will show you how to go by this, okay, how to find what the monotonicity or the bounded form of the sequence, okay, without going through what I'm about to teach you right now, okay. All you have to do is just stay with me to the end of the video, and I will show you that, okay. Right, so let's see how we go by solving this question, okay. So we have what? Let's look at the solution. Now we are told to what? Show that this sequence n plus 1 over n is what? Monotonic decrease or a bounded sequence, okay. So first, we need to write them in the form of what? Un and what? Un plus 1. So let's check. This is what? Un. So this is the main sequence, okay. So it's what? N plus 1, okay, divided by n. Now this is un plus 1. So for un plus 1, you just add 1 to the what? N. So we have what? N plus 1, okay, plus 1 divided by what? N plus 1, okay, right. So all you have to do is just try and then what? Simplify this, okay. So from here we are told that this will give us what? Increasing monotonicity, okay, and then un plus 1 being less than un will give us what? Monotonic decreasing, okay. Right, let's see how we go by that. Now, let's subtract the two, okay? Let's subtract them. So we have what? Un plus 1 minus what? Un, okay? And then that will give us what? N plus 1, all in brackets, okay? Plus 1 divided by what? N plus 1. And then we have what? Minus what? N plus 1 divided by what? N. So when simplifying this, we have what? N plus 2 divided by. Now let's find, okay, let's find the LCM. So we have what? N plus 1, okay, and then what? N, okay. So when you do the simple algebra, okay, you end up with what? This will give you n plus 2, okay. Hope you already know this. And then we have, right, so let's do simplification, okay. So let's move upwards, okay. Okay, let's see. Okay, so let's continue from here. So we are continuing from here, okay. So we have what? N squared, okay, plus 2n, okay. So from here, right, then we have what? From here, when you do simple expansion, you have what? N squared, okay, plus n, okay, and then we have what? N, okay, and then plus 1, okay, right. So we have that divided by what? N plus 1, and then multiplied by n, okay. So now let's do the simple expansion, okay. So we have n squared plus 2n, right. So we have what? Minus n squared minus what? 2n minus 1 divided by what? N plus 1 n. Okay, so let's do the simple addition and subtraction. So we will be left with what? Minus 1 divided by what? N plus 1, okay? N, okay? Right, so when you do a simple calculation, you end up with this, okay? So this is what? RUN, okay? Plus 1 minus what? UN, okay? This is what we'll end up with. Now, so from here, you can notice that the whole of this, okay? The whole of this is what? Less than or equal to 0, okay? So let me prove that, okay? So from the initial stages, we learned that UN plus 1, okay, minus UN has to what? Less than or equal to 0. So that we have what? A decreasing what? Monotonicity, okay? So that we have what? A decreasing monotonic sequence. In order to get a decreasing monotonic sequence, this has to apply, okay? So now let's see how we could prove that this, okay, is less than what? Or equal to 0. This, okay, minus 1 over what? N plus 1, okay, multiplied by what? N. So let's pick a value. So now we have what? Minus 1 divided by what? N plus 1, okay, multiplied by N. So now let's see. So from here, okay, there's no need to even compute this. So from this negative sign, you could notice that whatever value we insert for N, we'll end up with what? A negative value, okay? So let's put N to be equal to 1, okay? So we have what? Minus 1 divided by what? 1 plus 1, okay, multiplied by 1. So that's what? Negative 1 on 2, okay? So from here, you could notice that we have what? Negative 0.5, which is still less than 0, okay? Less than 0. So this is how we prove that a monotonic sequence is what? Decreasing, okay? It has to be what? Less than, okay, or equal to 0, okay? So let me write it over here. So for decreasing, this expansion, okay, has to be what? Less than or equal to 0. This is for decreasing, and then for increasing, okay, just keep this as what? A guide, okay? This has to be greater than 0, okay? So for decreasing, this is for decreasing, and this is what? Increasing. Now, remember I told you that once you stay to the end of the video, I'll introduce how you can easily solve this problem without going through any stress, okay? So now this is how you go by that. Let's see, okay? So let's see how you go by that. Let's check that one out over here, okay? Right, so this is what? This is the secret trick, okay? Sorry, the secret trick, okay? This is the secret trick. Now, so you have this question, okay? You have UN to be what? N plus 1 divided by what? N. This was the main question, okay? And then you also took time to find what? UN plus 1, which also gave us what? N plus 2 divided by what? N plus 1. Now, to check whether there is what? Monotonic decreasing or increasing, you just have to do one thing, okay? This simple thing, okay? Now, let N to be equal to 1, okay? So the problem is you have to make N to be equal to any reasonable value, okay? It could be 1, 2, 3, okay? But it has to be what? Any reasonable value, okay? Or number. So I'll just pick N to be equal to 1, okay? Let's pick N to be equal to 1. So picking N to be equal to 1, okay? From here, we have what? 1 plus 1 divided by 1. That's what? 2, okay? And then from here, this is picking N to what? Equal to 1. That's N1 plus 1, okay? So we have what? 1 plus divided by what? This N plus 1. So that's what? 1 plus 1. So this will give us what? This 0 and 2, that's 1.5, okay? So now, let's check this one out. So here we could notice that initial stages I stated that UN, okay, UN plus 1, okay, minus UN has to be what? less than or equal to 0 to give us what? A decreasing, okay? And then you have what? un plus 1 to be greater than 0 to give us what? An increasing monotonic what? So from here you can notice that this is the same as what? Okay, and then this is also the same as what? Okay, so now let's check something over here. So from here you can notice that un, okay, this is what? Un, and then un plus 1, okay? So from here, okay, we are comparing two things over here, okay? Let's compare, okay? I'm giving you the only approach you ever see, okay, on the internet, okay? This is the only channel you ever come across this secret trick, okay? Right, so let's see. Now, so from here you can notice that un gave us what? 2 by making n 1, okay? And then un plus 1 gave us what? 0 and 2, which is what? 1.5. Now let's check. Let's check, okay? Let's check. You can notice that un is what? Greater than what? Un plus 1, okay? And then from our principle over here, you can notice that once un is greater than, okay, or equal to un plus 1, okay, it means that what? It's what? Decreasing monotonic sequence, okay? So let's just ignore the or equal to sign, okay? Let's just ignore the or equal to part, okay? So let's just make it this way so that it will be simpler. Or you could introduce the un, but I want to make it a bit simpler, okay? Right. So let's say you can just keep it, okay? You can keep it or just omit it, okay? It all depends on you. But this is what I want you to know. Once you are given a question and then you substitute n with what? A reasonable value, okay? And then you find un and then un plus 1. After that, you compare the values, okay? So from here, you can notice that un is 2, un plus 1 is what? 1.5. It means that un is greater than what? Un plus 1. So it means that this principle applies, okay? So from here, you can notice that un is greater than or equal to what? Un plus 1. So it's what? Monotonic or decreasing, okay? But in case you would have come across un being less than un plus 1 or un plus 1 being greater than un, then that would have given us what? Monotonic what? Increasing, okay? I hope this was very, very helpful, okay? Yeah. Now let's dive right into what? Finding the bounds, okay? Now let's see how to find the bounds. In case you've already watched our video on bounds, okay, in our previous what? Tutorial, you wouldn't find any problems trying to find what? The bound, okay? You wouldn't come across any problem when trying to find the what? The bounds, okay? So let's see how. So in case you've watched our video on bounds, there's no need to even bother yourself, okay? So now you are giving un to be what? N plus 1 divided by what? N, okay? So let's pick reasonable values, okay? So let's pick n values to be what? 1, 2, 3, 4. And then let's come up with what? The sequence, okay? So let's see. So the sequence is what? So let's pick n to be 1. When n is 1, okay, when we put n to be 1, so we have what? 1 plus 1 divided by what? 1, that's what? 2. Let's pick n to be what? 2, okay? So 2 plus 1 divided by 2, that's what? 3 on 2. Let's pick n to be what? 3. So 3 plus 1 divided by 3, that's what? 4 on 3, okay? And then we have what? 5 on 4, okay? It continues like that. Now, let's see the bounds, okay? Let's see the bounds of these values. Now, for bounds, okay? For bounds, we need to pick what? The upper bound, okay? And then the lower bounds, okay? Now, let's pick the upper and the lower bounds, okay? Let's pick the upper and the lower bound, okay? So from here, we have an upper bound of what? Yes, you have an upper bound of what? So from here, you can notice that this is a reference point, okay? This is true. That's why initially I stated that once you watch a video on bounds, this would be very, very simple for you. But in case you haven't, we'll just link the video in the description, or you can go to our playlist on Algebra 2 so that you watch it, okay? I might link a card, okay, or just visit our playlist. Okay, so this is our reference point. So our bound will most definitely be what? Upper bound will most definitely be what? 3, and then what? Our lower bound, okay, lower bound is what? 1 or 0. It could be 1 or 0, but I most of the time advise you not to choose 0, but sometimes you could go with what? 0, okay, or 1, okay. So let's say it's 0 or, okay, so this will be our what? Upper and what? Lower bound, okay. These are upper and lower bound, okay. I hope this video was very helpful. I urge you to subscribe, and then I'll see you in the next video. Bye bye.